Hello, this is Testing Days. I'm Leo Arias, QA engineer of Ubuntu, and the topic of today's show is Ubuntu Core Kiosk. So we have a nice board, the Dragonboard here that we will show, and we attach a screen to this Dragonboard. We put a display server and a single application full screen, and we have here with us the developer of some of this code. So you will be able to ask a lot of questions here. But first, as usual, let's start with the round of introductions. Kyle, do you want to start?
Sure, I'm Kyle Fazzari. I've been here every week, so if you've seen this, you know who I am. But I'm a developer on Snapcraft, so I mainly focus on that and the general Snap developer experience. Zygmunt, do you want to go next?
Yeah, I'm Zygmunt Community. I'm a developer on Snapd and SnapConfine, and yeah, I'm gonna be a regular here as well, I guess. Alberto.
Hi, I'm Alberto Aguirre. I am part of actually the Mirror project team. So we put together some nice demos on top of Ubuntu Core and the Snappy system that we'll show you in a bit. But that's me.
And carrying on our collaboration with 96 Boards Open Hours, we have Robert here back. Robert, you want to say hi?
Yeah, hello, Robert Wolf from 96 Boards, engineer, community enthusiast. So yeah, fun times. Thank you for having me again.
Thanks for being here. Great to have you.
Yeah, thanks a lot to our two guests for this week. And you will be pleased to know that we have a new member of the staff. That's Zygmunt. He will be with us for the following sessions here too. Thanks for joining. So to start, we have Robert here for the first part of the session, so it would be good to start with him. And he has all the knowledge about the hardware on the Dragonboard. So Robert, why don't you tell us about the display capabilities of the board?
Yeah, thank you. So, I mean, basically, I was asked to talk about the display capabilities of right here. We have the Dragonboard 410C, and you can find this on the 96boards.org website. You just go to the products, consumer edition products, so 96boards.org. Display capabilities, right? So what we're talking about is essentially, in general, what you'll probably be using most is the full-size HDMI port right there. And you can find these specifications both on the Qualcomm Developer Network and 96boards.org, but I'm going to read off just what it says there. And it's a 1080p at 30 frames per second, video playback and capture with H.264 AVC and 720p playback with H.265 HEVC. And focusing on these, I mean, basically we're talking about the availability of a couple hardware decoders. And I don't want to go too much into detail, but essentially the HDMI port follows basic standards, right? So, I mean, these are the standards that are used by HDTV broadcasts. Essentially, some of these decoders used through YouTube or historically used in YouTube. And these decoders are in essence meant for mobile devices to help save battery. So instead of overloading the CPU with you know, these type of tasks, you have a dedicated piece of hardware that specializes in these decoding abilities. And they're ideal, right, for mobile devices. And essentially, the Dragonboard 410C being a very good development platform for mobile development, that's the idea behind this, right? Now, for those of you, I mean, I guess a lot of this can be Google searched, right? But I'll talk about it just for a second, is that you're talking about 1080p, right, which stands for progressive scan. And this is full HD video, 30 frames per second. This is bottlenecked due to the clock on the hardware decoder, right? So, I mean, you know, you get people in there designing these chips, and essentially the only way you're going to get 60 frames per second if your screen is a 60 hertz screen or 120 hertz screen, whatever it is essentially breaking the physical limits, right? So this is the physical limit of that particular decoder, and you're not going to be able to go much higher than that. I mean, other than swapping out physical components. So that is, in my opinion, a good speed frame rate. You're not going to really notice too much, I don't think. You know, you probably could if you were doing some like high-end gaming or something like that, whatever. But
well, as far as videos go, right? I mean, the Blu-ray standard is, I think it's only 24.
Hertz, so like frames per second.
Yeah.
Oh, so there you go. Yeah, so maybe the naked eye can't even really notice the difference. I know I've played some games with friends and they pretend to notice the difference. They're like, "Oh, turn up your frame rate."
Computer games are a little different, right? Because the response time is so important. But yeah.
Yeah. So looking back at the specification, I threw a couple acronyms out there. It is AVC when it was talking about the H.264 decoder, and that stands for Advanced Video Communications, and then HEVC when talking about the H.265, and that stands for High Efficiency Video Encoding. And this hardware was enabled in the Lenaro Debian-based images that you can find on the website. And I would imagine they're also enabled in the Ubuntu Core images or the Ubuntu images, because I mean it does use the Linux standards, right? So I mean, as long as you follow Linux standards, then they should be enabled, you know, globally. Now I'm not one to talk so much about that, but if you are interested in finding or reading up on some source code around this, I'm going to share this in the channel, and you can see kind of where the descriptions of this hardware enablement comes into play. So this is just get.lenaro, the get.lenaro.org website. You can go check that out and see, read through, poke through this code and find out more about how these particular interfaces were enabled. So yeah, any questions on that?
I find it really interesting that you have so many boards. Like every time you talk, I just watch at your wall on the back. Are they any different with respect to display capabilities? Are there some boards that are better than the Dragonboard?
So offhand, I don't know if I'm able to just quote stuff offhand, but yes, I do want to say that some boards, well, pretty much most of the boards will differ in a lot of ways. I mean, you know, graphics utilization, the frames per second capabilities. I want to say some of these are capable up to 60 hertz, but you know, in essence, you're going to find you know, these more extended version boards coming out with, you know, higher end chips, more powerful processors, more powerful decoders, and so you'll probably see more intense video capabilities on different boards.
Which one is your favorite?
So right now, I mean, I can't really say which one I have my favorite. I don't know if that's against Lenaro.
You love all of them equally?
I love all of them.
It's like with children, you know. It's just like you always have this answer. Oh, we love you equally, honey.
Yeah, my go-to board for a variety of my troubleshooting just happens to be the Dragonboard. But I mean, you know, I definitely have fun playing with all of the features of the different boards as well. So I mean, this one just happens to be my go-to in some of my troubleshooting. But I troubleshoot for all the boards using it, right? So it's yeah. How about that? That's all I have on the hardware side of things.
Anybody else with questions for Robert?
Yeah, thanks for sharing the products page. That's in the IRC channel.
Oh, just I have a question actually. You mentioned 1080p, but I'm not sure. Do you know if it's possible to go beyond that, like go 4K, like high definition video of 4K screen, or is that beyond the limit of this particular chip?
Yeah, so that I believe is beyond the limit of this particular chip.
Okay.
Though we do have other 96 boards with that enablement or with that capability. And you know, I don't want to cancel out the possibility of 4K on the Dragonboard. Don't quote me on that, but I do know that other 96 boards are capable of 4K.
All right, curious. Let's think about the demo. Super curious to see how that works. I'm gonna have plenty of questions about that.
Yeah, I have a question for you, Alberto. Do you know, like, the work required from our side to actually put a display server on this board?
You kind of broke it there at the end. The display server, what?
Sorry. Yeah, I was wondering if you were involved in the enablement of these boards to be able to show our display server.
Not for the Dragonboard, but for the Raspberry Pi 3.
Okay.
Just basically debugging the things.
Can you tell us a little about that? How do you get a board and then
what's involved in that process?
A monitor and
well, in the case of the Raspberry Pi, it was basically getting the right kernel parts essentially, and the kernel modules associated with that. So as of now, there's an open source driver called BC4 that supports the Raspberry Pi video core, which is Mesa compatible. So the Mir stack actually makes use of the Mesa stack. So any board that has Mesa drivers will basically work out of the box. Any Mesa compliant drivers with GVM support. So what's involved is really, in that case, was just combing through the upstream kernel distributions that they have for Raspberry Pi. Because I guess all these boards have like a different way of booting up and different ways of they set up the bootloader and the corresponding devices. So the Raspberry Pi 3 has this curious setup where the GPU actually is the one that boots up the board and sets up some of the clocks, some of the clock trees, and brings up some of the devices early on, so that you can actually have a console when you connect it through HDMI. So it was a matter of just finding out the right pieces and gluing the right pieces together. But after that, Mir, basically there was no changes required for Mir. It just worked on top of the Mesa stack.
And once you have Mir up and running, like let's say I built a snap that talks to Mir. I'm not embedding Mir myself. Will I need to provide something different for that snap to work the same way on the Raspberry Pi or the Dragonboard or any other board or device that has Mir snap available? Or is there something I need to put in my snap and put somewhere else that would let the magic happen?
Right. So that's kind of what the demo is about. So this particular demo, if you can see the other stream where I'm pointing my iPad at the monitor here. So that particular demo is Mir Kiosk Snap that's up in the store that uses the Mir stack and the Mesa stack to do the server-side job. And then there's a separate snap that it's actually the application snap, which you see here, which is right now I'm running a photo viewer example that comes from the Qt Examples Debian package, which actually pulls photos from the internet randomly and shows them to you. So this is running on top of Mir. Right now it's running on the Dragonboard, but you could install this on a AMD 64 machine. You can show that like in a virtual machine maybe later. This also runs in the Raspberry Pi 3 without modification. So it's just, as long as Mir runs on top of it, you basically, there's no changes required for that.
This is just a QML app, I'm assuming.
So this is just a QML app. I didn't write this. It just comes from the examples of Qt, and have here a keyboard connected to my Dragonboard. So just kind of showing that this is actually functional. You can see photos. So the purpose of this particular demo is that you can have a very minimal system, which is Ubuntu Core, together with an extra snap to bring in the Mir server or the Mir display server. And then you can run, a fairly simple app on top of it for kiosk type applications, right? So you can imagine this being like maybe like a photo frame kind of thing, right? I have other demos that you can have maybe a news, RSS news kind of display. This is also another Qt example, so no QML app. So this is all using the Qt 5 stack that runs on top of Mir, which itself runs on top of Mesa. So here's an example of just, looks kind of blurry, but this particular example just pulls news from the internet, shows them to you. So you can imagine this being useful in somewhat like those airport displays, right? That
so
shows
I see a
stickers
little
and
mouse
stuff like that.
cursor. There's like a little mouse cursor moving there. So obviously you're using a mouse, but say this was a touch screen and the touch screen was enabled.
Yeah.
Would
Right,
this
this would
actually
also,
translate?
Yeah, this will also work with a touchscreen. It's just that my particular demo setup here is a mouse and a keyboard.
Okay.
That's what I have. But some other people have actually
And
shown.
I'm very happy to have you here with us, Alberto, because I literally know nothing about this.
So I'm just going to go through another application. So here's like a stock ticker kind of thing. And this is all live. This is pulling stuff from the internet right now. So this is all running on top of Mirror, and you can go like full screen. So this is what we call a kiosk type of demo. And you can, you can imagine this being useful for like digital signage or, stuff that you see like on airports, right? Where you see like flight information or, news scrolling by and stuff like that. And requires a very minimal system, just Ubuntu Core and a couple of snaps, and you're up and running.
I have a question about the. So it makes sense that there are essentially two snaps here, right? One is the Mirror server, the other one is the Mirror client, right?
Right.
You just talked about some of the work you had to go through to get this working on the Raspberry Pi. Is that work part of the image for the Raspberry Pi, or does that mean you had to do something special in the server snap?
No, that work is part of the what we call the gadget snap for the device. So
okay.
that's part of the image for Raspberry Pi.
Okay, so the server snap then is the same code base essentially. I mean, I assume you have to rebuild it, but
so the server snap, because this core image is very minimal, you don't want to include like the kitchen sink in it, right? So you might have some products that don't need UI at all, etc., or sound or anything like that, right? So we're taking an approach of where you have these multiple pieces that you can bring in to kind of give you that capability. So in the case of like UI, the base capabilities to have a display server. So that's brought up with this Mirror kiosk snap that we have. If you're looking for something that's minimal and you don't have, you don't want to have like full-fledged windowing support and all these things that you would have with a full desktop system, this is something probably you would be interested in, right? So the base capabilities like the kernel modules and stuff like that is part of the core plus gadget snap image. Or I should say the image has, the core snap, the kernel snap, and the gadget snap that all make up this single image.
right.
That has all these kernel level things that you can do for the most part. And then you can bring in extra snaps to give you more support, for like audio or display server or et cetera, right? So this particular demo that I'm showing you right now is, you will download a Mirror kiosk snap that gives you the display server capability, and then you can run your application snap that makes use of the Mirror interface.
Now, is this easy / stable enough that someone running Ubuntu Core on the Dragonboard could run this, or did you have to work around a couple of things?
So right now it's fairly experimental because we're trying to figure out some things in regards to like sharing Mirror libraries so that the server and the client are, talking the same protocol. But you can't. It's up in the store in the Edge channel, so you can definitely download them and play around with it. We will probably put updates that will break stuff. So it's not quite ready for production, but you can download and play around with it. Yeah.
Okay. Well, the reason I ask is we have a question here from Tim DH asking if we're going to demo setting up Mirror and any of the supported snaps on a board or a VM. Now, Leo, I know you were working on getting that working in KVM. I'm not sure what progress you've made.
Yeah, I'm on it, but connection is terrible here. But I can show you. I set it up on my Dragonboard actually. So
it would be fun to kind of walk people through that if we have a couple minutes for it.
So yeah, we can go through the instructions. So that's my Dragonboard, and in here it has the HDMI cable that goes to this monitor, but it's the same monitor that I'm using to watch you. So let me see if you can just see it a little. So I can see you now, and I'm not sure if you're hearing me, but that's the browser running on.
Now make sure you're selected, right? I don't know if you still got his screen selected.
I don't know if he actually hears us, if he has the sound coming out of the same thing.
I heard you, but I don't know if you were able to see anything. I was showing you the browser, actually the same browser that we have on the phone, running on the Dragonboard on my monitor. And if I plug this, you will have to trust me because this.
It's a little hard to see because it's super bright, but the border of the monitor was too dark, so it was overexposed.
Trust my words, this is awesome. The work Alberto and his team are doing, it's incredible. Like if instead of plugging this Dragonboard to my monitor, I plug it to a touch screen, I actually have like a do-it-yourself phone. And actually, you were talking about that a little some days ago, Siga, right? Like prototyping a phone with one of these boards and components that you just plug in. Why don't you tell us a little about what you have in your mind there?
I was just like discussing with a colleague of mine. We used to work together a while ago. Actually, it's kind of ironic because my first job was doing embedded set-top boxes. So you want to play you want to play some movies or TV series, stream them over the internet, have them decrypt with some DRM and display your screen. But back then, doing that kind of stuff was crazy. I mean, it was super difficult to just get anything up and running. You basically had some BSPs, maybe some samples, nothing really worked. It was super expensive and difficult to work with. So just looking at, you get a board that's like under $100, you plug it in, it's relatively beefy, it's got enough memory so you don't feel as strained as you do on some of the other boards. You plug the HDMI cable, you snap install Mir or Mir server, I'm not sure what the snap name is. And then you can essentially start deploying your apps and thinking about what you want to do. I think this is really amazing how we've gone from you need a group of engineers that can essentially hack through the kernel all the way through this all the way out. We had hardware debugging devices as well. It was crazy and complicated to the point where you can open VI, edit some QML, build or even try a snap so you can keep editing live and it's going to just refresh for you and it's just going to keep running. And I think it's gone from being extremely difficult to just being like editing websites. I think this is really, really amazing, and it's actually on devices, on real hardware. And that hardware is the thing I really like about those development boards is that not only they're like not really expensive, they're always cheaper boards. They're always like boards like $5 cheaper, but they're actually boards that represent the hardware that you actually see in products. It's not like this company made a cheaper chip that they sell, but no one really ships this. This is real stuff, and I think this is amazing because people can then start to use this to create in their own home a prototype for something that could be the next great thing. And we removed the vast majority of the difficulty. Linaro is doing an amazing job by making the kernel nice and just like it's not the crazy days anymore. This immense amount of improvements in the kernel development process around ARM. It's not as fragmented anymore, and the drivers are getting. The video drivers are always crazy, but they're also getting better. And I'm not quite sure if the user space part of this is free software. I'm not sure. Alberto, you could probably correct me if I'm wrong. I believe people are trying to make this free software, and there's an ongoing process, but I don't know what the current state is.
Right. So in this particular example, it actually ties up to the question about performance I saw on the channel.
Yeah,
we're right now relying on the free Drino driver because it's Mesa compatible. So
free software.
Well, yeah, it's free software. It won't be it's not as performant as the binary blobs from Qualcomm itself yet, right? So probably performance is not where it can be still, but yeah, it's free software, right? We're relying on that part of the stack. So that comes with Mesa. That's part of the Mesa stack.
So just like imagine like 15 years ago, none of this would have been as easy, or even some of this was even remotely possible. So just like acknowledging the amazing development, amazing progress made over the years as a community of people. I think that's really amazing. And these boards are a huge part of that because they're just available. You can really buy them. They're not out of stock. You can just get them.
Right. I mean, you can get, a Dragonboard, a Raspberry Pi for $35. And if you hook up Ubuntu Core to it, you can just download the Mirror Kiosk, Snap, and you can do simple photo. I see a lot of like photo frames, DIY stuff. That would be like perfect for that.
So actually, a very simple question. So you mentioned this is the Mirror Kiosk Snap. Can I snap install this on my device? Is it published in the store? Can I just snap install it?
Right. This is in the store in the Edge channel right now. But yeah, like all these demo applications, they're all up on the store. Yeah.
And where's the source code? Because I bet you get up and running, you plug in the monitor, you get excited. This actually works, and I like to tweak something. QML is kind of like HTML. It's not that difficult to learn. It's not like it's super known by many people, but once you actually see it, it's kind of this aha moment where stuff clicks in and you can change things. So I think it would be great if people could just like download the Mirror Kiosk Snap source code, tinker with it, even perhaps on the device itself, because it's QML. You can always snap try it, which means that you don't have to rebuild the snap over and over. You can just snap try and edit away. It would be amazing if we give people pointers to the source code so they can try this themselves and tinker.
Right.
I think tinker is just...
Yeah, we actually have this up in Launchpad. So I'll probably post the link there to the channel and just find it.
And while you're looking for that, we've got another question here from Taybot. Curious, what are the milestones to actually see the Mirror Kiosk in an off-the-shelf device? And I would have no idea how to answer that question, so feel free to say not my area of expertise, but curious what your thoughts are there.
Well, from the technical side, we're working towards Mirror 1.0 release, so we can stabilize AVI. So from that point of view, that still needs to happen. But on an off-the-shelf device, is really up to OEMs and things like that to kind of take this technology and run with it. So other than that, I mean, it's up to product managers and stuff like that to answer questions like that. But
yeah, definitely. Well, I mean, one of the big unblockers for something like that is supporting various pieces of hardware, right? Which we're making good progress on. So.
Right. So basically, if you have a compatible driver that works with the Mesa stack, an equipment manufacturer could just roll with this and ship it out pretty soon. As long as there's still a few pieces that have to land, before that can become like something that a user can actually buy and put in their homes. Yeah. But I think we're getting closer every day, and we're fairly close.
All right, well, thank you. And yeah, as the Ogre mentioned in the channel, yeah, we can hear you.
Yeah, Leo, go ahead.
You may be having some issues there, so we're just gonna throw this out there. Ogre mentioned in the channel that not only do you have the Mirror server, or, the Mirror Kiosk demo, but you can actually snap install the Unity 8 session snap to get a feeling for what the base desktop would feel like on a Dragonboard.
I think I might be able to show you something. So let me share my screen. If you stop hearing me, please yell, because I don't know when I'm talking to myself. And when I'm doing these demos, I spend like 5 minutes showing cool things to only myself.
Costa Rican internet, yeah.
Yeah. So this website, we will send the links out there. It's the pointer to all of what Alberto has been talking about. And well, basically, you have to start with an Ubuntu Core machine. Somehow, we have gone through ways to set it up in a KVM and in a Dragonboard. So Alberto showed his Dragonboard. I have mine here, but I'm also trying to set it up on a KVM. So everybody can help, not only if you have the hardware, because it's this idea of sharing the same code everywhere. So if the code works for you in KVM, it's pretty probable that it will work on the Dragonboard. And if it doesn't work somewhere, it would be good to know. So if you have
Yeah, I see your video, but I don't hear you, Leo. Are you?
I think we just lost him because when I click on his feed, it doesn't focus, doesn't go full screen.
Yeah, oh yeah, it doesn't do anything. You're right.
So I'm actually curious. So I'm gonna just use this moment to
go for it.
And I have a question about something. So imagine I want to ship an application that I want to do some graphics. So maybe I'm using Mir and I'm using OpenGL. And where's the OpenGL user space part? Is it? I don't want to ship it in my application. That's kind of like feels wrong because maybe this is going to be this next device. It's just like,
good question.
This is not for this device. Where is it supposed to live? Right now we have the Mir server, but again, it doesn't feel like it should live in the Mir server because what? It's going to ship everything. It's going to be like for every new device, there's going to be an update. Doesn't feel right either. I think we need like a third box for that specific part for the user space library, right? What do you think about this?
Yeah, I mean, that's part of the question that we have to resolve before any of this is production ready. I think one of those boxes could be the gadget snap, right? Because
yeah, I guess
the OpenGL implementations are usually tied to the particular hardware.
Or it could be the kernel snap as well, because the kernel is just like we ship the kernel to snap, but it could be kernel plus something else. It doesn't really have to be just that.
Right. True. But yeah, I guess probably the gadget snap is the thing I would say. It should probably live there, especially for the embedded devices. Now for desktops, that's a slightly more complicated question. I guess.
I don't think the gadget snap is perfect for that, because if you think about if you have a device that you've made, and you want to make a device that like you take the Dragonboard, put it in an enclosure, call it something else. You're actually supposed to create you don't have to create your own gadget. Maybe they're right. Because I was trying to say that if everyone that's going to make a device will have to fork the gadget for some reason, then this will be a very annoying story for people. They just may have to maintain this OpenGL stack, and that's not what they should be doing. But if we can actually not have them clone the gadget and just reuse the stock gadget, I think that's sufficient, yeah. And then, yes, I think it'll be a nice place to just ship those extra libraries, and we can pick them up from there. We have the Kotlin interface for that.
Right, so that makes sense for like embedded devices where you have one piece of hardware doing OpenGL or GPU. I don't know how it would work for like desktops where you can just plug in any
yeah, I think that's really interesting. We have some support code for. I mean, on a desktop you would typically run classic Ubuntu and not core Ubuntu, at least just not yet. And you can easily swap hardware on most of the devices. So I think we need some kind of different mechanism there to provide you have this hardware, which kind of drivers are necessary for that, but let's just get them somewhere. We need to figure out how this is supposed to work, but I think it's, the story is different. The gadget should not be shipping that on the PC.
Right.
So Leo, are you with us? Sorry for jumping in while you were disconnected for a second. I don't think either is really patient.
I don't think he's with us.
No. Okay, do we have any questions on the IRC channel? Just scanning it now.
I don't believe so.
No.
Answer all of them.
Hey, Leo, you're muted.
You're unfrozen.
No. Were you able to see anything at all?
No! You were disconnected like 5 minutes ago.
Oh, terrible.
Next time, I have Dragonboard as well. Next time, you could just put me off a day early. I can prep some demo. I have a second screen I could show this on.
Yeah, I will try one last time just quickly. I don't have
Okay.
the apps running yet, but if I speak too fast, maybe you will be able to see this. So here is my Ubuntu Core KVM.
Hey, it
And
works.
this is actually Mir running, just it's not showing anything, but well, there's the UI. And in here, I'm trying to install the snaps. But
And we've lost him again. At least the audio.
Oh, right at the pivotal moment.
Yeah. But wait, is the video still going? No, it's off again. Oh man. Well, so next week I'm just gonna, I'm gonna put my Dragon board on my desk. I have all these boards up on the shelf. They're running. I have like 6 or 7 different boards, but they're like all headless. But I think for the Dragon board, it would be a nice thing to have. Hey.
Hey, Leo.
Do you know the joke, by the way? We lost you again. And you can't hear you either now.
That's true. I can't hear you. Well.
Snap install post audio, man. No. Once I had issues with my microphone, there were a bunch of people in the meeting, in the kind of important meeting, and so I just quickly grabbed a piece of paper and just like scribble on it, like it doesn't work, and just like hold it up. Anyway.
Well, are there any other questions? I don't know that this walkthrough is actually going to happen today. We can try it again for next week if we want.
I don't see any questions. I think we should add all the links to the source code and the web pages we mentioned and that were shown in the RC channel. And when this goes to YouTube, we should add them there so people can click around, and we can link the second demo we're going to do at the bottom as well, I guess.
Okay. I think I won't be able to show anything here, but we'll share links. There's the page. You can go through the steps and do it by yourself on a KVM. It's actually pretty simple. Do you have some other questions to Alberto? Or Alberto, do you want to talk to us about something else?
No, he answered all my questions. I really appreciate that.
No, I think that's pretty much what we wanted to show.
Okay.
Just like I have to summarize is the goal here was just to show, just using really basic snaps and components, you can put it together very quickly, like some compelling demos, right? Like you were saying before, you could also run the web browser app that we used to have on top of Mir Kiosk. That still needs some polishing, but that's also something that works. So for example, you can imagine yourself making a product that's, just based out of HTML5 pages, right? Maybe you're showing digital signage or something. And you want to deal with Qt maybe, and you just want to do HTML5. That's also, pretty much almost there. Yeah.
I had one last question that I told you about, almost forgot, and it's that this is way more secure than X11, right? That's why Mir started. Why is that? Why is it that X11 is so insecure, and what's different on Mir that makes this so much better?
Well, one of the things you can do with X11 is any application can request input, right? So if you ever played around with the application XIs, right, that's like a perfect example of that problem, where you install XIs and the eyes follow your cursor, right? Doesn't matter, what application you're in, it still follows, it still gets input. So from that point of view, if you were to copy, sensitive data, passwords, credit card numbers, etc., there could be malicious applications installed in the background doing similar stuff to XIs that can just intercept all this stuff.
So it's not just the input, it's also the clipboard as well. So I copy paste something, all the apps can see it.
All the input, all the copy and paste stuff. It's because that's the way it was designed, right? It wasn't designed to deal with the world that we live in now, right? So with Mir, you have more separation of concerns, where input is only delivered to the application that's focused. And on top of that, when you run stuff on the Ubuntu Core, you also have confinement, where you get all the benefits of seccomp and app armor. On top of that, architecture design change. So I guess unless we go into the details, that's kind of like the high level of why.
That's pretty good.
That's more secure.
Thanks a lot, and we will be playing a lot more with UI in the Dragonboard in the following weeks. So we will be bothering you again many times with many questions. Thanks for joining us, and do you want to say bye?
Thank you very much, Alberto. It was good to see you.
Thanks, man.
Thank you guys for having me.
Bye. And next week we will not have a show, so we will see each other again on March with more interesting topics about Ubuntu Core and testing. But next Thursday there is a show on Open Hours. That's 96sports.com, I think, /Open Hours. We will be sending the announcement soon. And that's a show with Ogra and Jamie Bennett from Ubuntu Core. They will be talking with Robert about Ubuntu Core and the Dragonboard, and many more details about how to enable one of these boards, how to put a kernel, and how to put an Ubuntu operating system on top. So if you have more questions, feel free to join them. That's all for this week. Thanks a lot. Bye.
All right, thank you.
Thanks, guys. See you.
See ya.